Two concurrent processes P and Q should access a resource A such that P should access a resource A before Q. How many minimum semaphore variables are required to perform the same? Here there are two processes, process P and process Q. Both the processes should access a resource A. And the condition is P should access a resource A before Q. How many minimum semaphore variables are required? We shall start with a single semaphore variable. Here P can make use of A anytime, but if Q tries to use A, it should wait. So we shall initialize the semaphore with the value 0 and can make the process Q wait for this semaphore. As a result, if Q tries to use A, since the value of S is 0, process Q cannot. Now process P, after using A, execute the signal function on the semaphore. As a result, S value becomes 1 and then Q can make use of A. So Q will use A only after process P. Now consider this question. Two concurrent processes P and Q access two resources A and B in order. And there are two conditions. P should access a resource A before Q. Q should access a resource B before P. How many minimum semaphore variables are required to perform the same? Here also there are two processes, process P and process Q. The processes are accessing two resources A and B. The condition 1 is P should access a resource A before Q. P can make use of A anytime, but if Q tries to use A, it should wait. So we shall initialize one semaphore variable with the value 0 and can make process Q wait for it. Now P can use A anytime. After using A, P should execute the signal function on the semaphore. As a result, process Q will use A only after process P. And the second condition is Q should access a resource B before P. Q can use B at any time, but if P tries to use B, it should wait. So suppose if we make the process P wait for the same semaphore variable, what happens? There is chance that as a result of this signal function, there is chance that the process P receives the signal from itself and it can make use of B without waiting for process Q to use B. So here process P should use B once the signal is received from process Q after using B. So we shall make use of one more semaphore variable. This one becomes S1. The next semaphore is S2. We shall initialize S2 with 0 and can make process P wait for S2. So even if P tries to use B before Q, it cannot since value of S2 is 0. Now Q can make use of B. After using B, Q should execute the signal function on S2. Now S2 value will be incremented. As a result, P can make use of B. Hence, P will use B only after P completed using B. So here the minimum number of semaphore variables required is 2. Now consider this question. Two concurrent processes P1 and P2 use 4 shared resources R1, R2, R3 and R4 as shown below. There are 4 conditions. Condition 1. P2 complete use of R1 before P1 gets access to R1. P1 complete use of R2 before P2 gets access to R2. P2 must complete use of R3 before P1 gets access to R3. P1 complete use of R4 before P2 gets access to R4. Find the minimum number of binary semaphores required. Here also there are two concurrent processes, process 1 and process 2. They are accessing 4 shared resources R1, R2, R3 and R4 in order. The first condition is P2 must complete use of R1 before P1 gets access to R1. Here P1 cannot just access R1, it should wait for process 2 to complete using R1. So we can make process 1 to wait for a semaphore which is initialized to 0. As a result, process 1 cannot simply use R1, it should wait for the semaphore. Once process 2 completes using R1, it will execute the signal function on the semaphore. As a result, P1 can use R1 by executing the wait signal on S. The next condition is P1 must complete use of R2 before P2 gets access to R2. After using R1, process 1 can use R2, but process 2 can use R2 only after process 1 completed using R2. So here process 2, we should make process 2 to wait for this semaphore. Suppose we use the same semaphore S which is initialized to 0. Now what happens? Because of this signal function, after this signal function, before this wait, if this wait executes, process 2 can use R2 before process 1 use R2. So here process 2 should wait for the signal which is produced by process 1 after using R2. So instead of one semaphore, we have to use one more semaphore. So let this be S1 which is initialized to 0. We need one more semaphore S2 which is initialized to 0. So here process 1 should wait for S1 and process 2 here produces signal function on S1, and here process 2 should wait for S2 which is initialized to 0. After using R2, process 1 should execute signal on S2. Now process 1 will use R1 only after process 2 completes using R1, and process 2 will use R2 only after process 1 completes using R2. So the first two conditions are satisfied. The third condition is P2 must complete use of R3 before P1 gets access to R3. After using R2, process 1 cannot just access R3, it should wait for process 2 to complete using R3. So here process 1, we can make process 1 to wait for a semaphore, and we can try making use of the same semaphore variable. Suppose here we wait for the semaphore S2, what happens? Because of this signal function, after this signal, and before this wait, if this wait executes, process 1 can use R3 before process 2 use R3. So here process 1 should actually wait for the signal which is produced by process 2 after using R3. Thus instead of S2, if we wait for S1 here, then it will be fine. Process 1 should wait for the semaphore S1. After using R3, process 2 should execute signal function on S1. Since these two waits will be executed in order, after this signal this wait will be executed, and after this signal this wait will be executed. Now process 1 will use R3 only after process 2 completes using R3. The last condition is P1 must complete use of R4 before P2 gets access to R4. So process 2 cannot just access R4, it should wait for P1 to complete using R4. So here we can make process 2 to wait for a semaphore which is initialized to 0. Suppose here we use the same semaphore S1. What happened? After the signal, before this wait executes, if this wait executes, then process 2 can use R4 before process 1 use R4. So here if we wait for signal S2, then process 1 completes using R4, then execute the signal function on S2, then process 2 can use R4. These two waits will be executed in order. So this wait follows the signal and this wait follows this signal. So after using R4, process 1 produces signal, which is, as a result, process 2 can make use of R4. Thus process 2 will access R4 only after process 1 completes using R4. Thus all the four conditions are satisfied and the minimum number of binary semaphores required here is 2.